It's only been 15 minutes. I thought it was like an hour.
We're having some fun now.
Hi, and welcome to the Hackaday Podcast. I'm Tom Nardi.
And I'm Dan Maloney.
This is episode 272, Desktop EDM, Silence of the Leaves, and the Tyranny of the Rocket Equation. And this week, we are not joined by Elliot Williams. He's on vacation.
We're flying solo here.
Yeah, we're like Icarus. We're going to see how close we can get to the sun before we're melted. We've never actually tried to do this without Elliot before. In the times he was absent, I would do like a clip show kind of thing of recorded segments, which we all know is the most creatively bankrupt way of putting something together. But it is easy, right? So any failure in the technical aspects of this episode, I mean, I guess are my fault, but Elliot is not completely without blame because
he's good. He
should have stayed at home. Yeah, or at the very least brought his computer with him.
Right, to Elba.
But no, of course, Elliot does deserve his time off. Although I, for one, will be glad to have him back next week. Well, in the meantime, we still have over a month to go, right, on the business card contest.
Yeah, it's always fun to see the projects that, or the contests that are based on a serious constraint, like the coin sale challenge or the business card challenge. Something where you can't spread out, you can't, haul in all kinds of resources. You have to put everything in a very small package with a very low budget for power, and it always ends up making for interesting projects. And we've seen quite a few of those.
Yeah, absolutely. I feel like we've talked about this before anyway. When we can kind of paint them into a corner, that's when they really impress us. And it's also a little, I would say, on our end, I feel like it's a little easier to do the scoring and the judging and everything because there is kind of that baseline.
Yeah, exactly.
So this kind of brings them all onto a more even playing field, which I think is a little fair, I guess.
Yeah, these cards are. It's not something you would want to keep a stack of in your pocket, but maybe one. That's no problem. So yeah, we'd love to see some more entries pull in or come in and see what people are coming up with, because there's some pretty cool stuff already. Go check it out.
This is a journey into sound.
What's that sound?
What's that sound?
Okay, last episode they played the sound, and now we get to look at people's guesses and pick a winner. Did you actually listen to it, Dan? Do you want to hear it before?
Let's see, where is it here? What's that sound? Wave? I guess that's it. Here I go. I think that's the bloop.
Every time I'm on, it's like the weirdest sound that I never know. It's like, okay, it's two Scandinavian screws bouncing off each other and falling down the steps. And then the time it's something I knew immediately is when I have to,
when you have to keep quiet about it, right? Yeah.
Yeah, right. But yes, it is the bloop. Famed deep sea monster noise. I think now the consensus is probably icebergs rubbing up against each other or breaking up, something like that.
The loudest sound ever recorded underwater, something like that.
Yes, and then I think like every time we hear it, like now, it's like super super sped up too, right? I think
right. That's like
originally
60 times
it was
faster,
right,
or 600 times faster, something like that.
So, like, what we think of as the bloop never really happened. It's like, just made to be a fun soundbite to get people excited when they're watching Unsolved Mysteries or whatever.
This is what you would have heard if it was an actual sound.
Yeah, if this existed, this is what it would have been like. And then, I thought, and I was pretty sure it was the bloop, and then I went on YouTube to just, like, double check, and then don't go down that rabbit hole.
No.
Because then they're all like, these CG renders of monsters and like the loop discovered 2024 confirmed. What the Illuminati don't want you to know. Well, we got 21 answers on this one. And by my count, 11 were correct. So that's not bad. That's half. And I would say even the ones that weren't right are pretty close. A couple people said hydrophones. Somebody said the fish aquarium bubbling pirate chest thing, which I almost want to give that to him on a technicality. I like that one. There actually were a couple like different one's bubbles under the ice. Somebody said microphone in a fish tank. I think everybody kind of got the, Oh, there's even a second one. It says air chest at the bottom of the aquarium where it opens and the air escapes.
Very, very close. Yeah.
We got one Ocean Gate Titan implosion.
Ooh.
Oh, that was a little soon. So now we have to pick a number between 1 and 11, and I know Elliot usually has a clever way to do this, and I didn't think about it until just now. So
roll the dice twice and see what it comes up to me.
I had such grand plans. I was going to do something like, count how many words are in the last Hackaday comment, but there's a huge chance that's more than 11 words. Well, since we're doing the budget podcast sans Elliot, I'm just going to use an online random number generator that lets me pick a maximum and minimum. I will come up with something more nerdy for next year when I have to do this. And the number is 4. Let's say it's 4. Who is 4? Answer is the bloop, probably. The sped up sound of breaking iceberg scientists caught on hydrophones. And that is from FL42V. This is the tricky part because I don't know if Elliot has like a list of people who've won before
right.
that are supposed to be excluded. So tentatively, you're the winner until my boss tells me otherwise. So, somewhere in Italy right now, Elliot's listening to the podcast. He's like, oh, God.
He's just shaking his head.
I got to give somebody some bad news.
I'll never leave again.
I also don't know the mechanism to have a shirt dispatched to you, so allow for a few more days for Elliot to come back and figure out how to do that. But I promise you, nothing. I can promise you nothing.
There's no promises.
I can promise you nothing, although other than I read your name off of a list. So, and you were right. I can give you that much. You were right. Well, I suppose that means it's time we get to our hacks. And for this first one, I was kind of bummed that we had to run it at like 1 a.m. on a Saturday morning. It was just the nature of the beast. Sometimes that happens with what's available in the queue. This is NetBSD bans AI generated code from commits, and I think this is super topical and very fair. They made the argument that these AI tools are trained on code sniffed from all over the internet, that there's no way to tell what the original license was. Was it, did it come from some book of, my first programming that's copyrighted to some dude? Is it Creative Commons stuff? There's no way to know what it learned on, right? And we've seen in the past that sometimes these like Copilot and these other tools, they'll pull whole functions right out of existing code. I mean, people have identified stuff like, hey, that was, that's a decompression module from Half-Life or whatever, stuff that's kind of known in the community. So it's totally possible. It might pull a few lines from something that is not in a compatible license, right? So that's right off the bat. That's a big problem. Like they don't want stuff in there that has a nebulous license behind it. And the other issue is, the AI generated code kind of sucks most of the time, right? So you probably don't want it in your project anyway, even if they could say, oh, this is definitely, BSD or licensed and it's going to be compatible, but it is some AI hallucination. It doesn't really help matters. It's we still don't want it, right? So I appreciate that they even gave to the two arguments here, that it was a license thing primarily, but then also just like a competency issue, right? Like we don't want this janky code in NetBSD. I mean, I would have just I wouldn't even explain to myself probably if I was behind. I would have been like, no AI code. Like it seems like a simple line in the sand, right? Like we don't want AI code. What is it? We're trying to make an operating system here. There's a certain expectation in the BSDs of stability and that kind of thing, and you're not. If you need to use Copilot, you're probably not the kind of person we want. Submitting code for NetBSD. I think that's
correct.
A fair stance. I mean, it might be, is that gatekeeping? Is that some elitist thing? I don't know, but at least with the technology now, that we have, it's just not ready for that kind of prime time. If you want to use, this kind of stuff to help you with some Arduino code because you're just getting started, that's great. And it's cool that is out there. We've seen people submit projects that say, hey, I don't know any programming. I know the hardware, and ChatGPT got me the Arduino code. That's cool, and that's helping more people get into it. But like that has no place in an operating system that's running on servers that people rely on.
Yeah, but I mean, I guess my problem with this whole thing is, how is this different? How is a ChatGPT generated blurb of code that does at function X, I don't know, a bubble sort, different than me going to StackExchange and saying, hey, how do I do a bubble sort? And someone says, here, and gives me the code, and I say thanks, and copy it and paste it and put it into my application. Is it? I guess what I'm trying to get at is there's only so many ways that you can do a particular task in programming, and the creativity to me it seems to be the part where how you put it together. So you say, okay, I need to do a sort here. I need to do, a list enumeration here, or something over here. I put those all together, and that makes an application that does a unique thing that hasn't been done before, or hasn't been done quite that way, is more efficient, is smaller, cheaper, better, something that sets it off from, previous applications. And using a large language module, or a large language model, to generate those bits of code to do the well-characterized functions of a larger application, to me doesn't seem all that different from just asking someone how to do it, or even, pulling it out of a textbook, or just pulling it out of your memory from when you took that class. It seems like the difference between them is very, very fine, and we're kind of painting everything with this AI brush that, AI bad. And I don't necessarily see a big difference between that and, like I said, like just going out and copying someone else's code.
Yeah. I mean, I think that's fair, and I think
maybe I'm being naive, but
no, and I think a lot of the comments kind of went in that direction too. Even though it was released at 1 a.m, we still got plenty of late night commenters.
Yeah, we did get comments.
But I would say that if ChatGPT and not to pick on that one in particular, but just this technology in general, if it didn't have that tendency to hallucinate and combine things in weird ways, I think the comparison would be a lot cleaner. I mean, if you go on go anywhere, right? Go on whatever you want to do, or even, like I said, open a book and read it. Like, that code is going to be presumably done by a human and will work, right? It wasn't just made up from fragments seen elsewhere. And I guess what you're saying is, like, that person who wrote it might have made up from fragments they saw elsewhere, but like at least a human wrote it down and it was in the loop, right? And at least ran, hopefully, the thing, whereas you go on ChatGPT and say, hey, write me a whatever, and it's going to take a line from here, a line from there, combine it into something that thinks looks correct, and maybe passes like a syntax check. But there's really no more thought than that, you know. So I think it does. It's not like it's vilifying asking for help. It's just who you're getting the help from, and is that help from a trustworthy source, you know. And then also, kind of a secondary thing, somebody in the comments pointed out that at least right now, in the eyes of the Copyright Office, you can't copyright something that a human didn't make. Like there has to be
Right.
copyright. It says copyright can only be granted for works of human authorship. You know, so that gets to be a gray area. So even if the code was coming out of this tool was perfect and worked 100% of the time, is it invalid for copyright purposes because a human didn't author it? And that's a whole other rabbit hole that projects don't want to have to necessarily go down. And like I was saying before, like this is all really just talking about the current generation of these tools. I mean, this argument might be moot in another decade when this stuff is
Right.
way better, and maybe the computers do all the coding, right? And we just sit back and we use our hover fat people chairs from Wall-E because we've now transcended having to do things ourselves, right? So this could just it'll be very interesting to look back, actually,
Yeah.
in these early days and these debates that we're having, and are they going to seem foolish? I'm reminded of PSA. Did we write about it? Actually, it would be kind of cool. It was like a short film that they made to like transition people from rotary phones to touch tone.
Right.
And it was like, these people are like, oh, this stupid thing, I don't trust it. This is how phones work. Why do they have to change it? And, it's like, oh, but Grandpa, the new touch tone phone. And, watching it now in 2024, I'm like, well, you're all ancient news. Like, I don't even have a phone on the wall anymore. And you guys are arguing about, which one is the superior wall phone. So I do kind of wonder, when is that going to happen, that we'll look back and be like, oh, I remember when we were worried about this kind of stuff. And now it's just, business as usual.
When we're sitting around campfires, grilling up squirrels and say, yeah, remember when?
Yeah. When did the revolution start? Was it when we let the computers do everything for us? Yeah, probably.
Didn't we see that movie before?
Yeah, when we're being, rounded up into camps by bipedal combat robots. I'm like, you know what? Maybe NetBSD had the right idea.
Okay, first up for me, I think this one's important too. Beta aims to bring wire EDM to the desktop. At first I saw this as beta, and I thought they were beta testing something, but no, beta, as in the fish, because this EDM machine, or electrical discharge machine, fits into a 10-gallon aquarium. So they called it beta. I thought that was pretty clever, but the whole idea of being able to do EDM on the desktop is really, really intriguing to me. Yeah, it's exciting to see chips fly from a CNC machine, even a CNC router that does wood or aluminum or, lightweight materials, plastic and stuff like that. Super interesting to put those machines together, to watch them work, to program them, and to make miraculously clean and precise and beautiful parts when all goes well from the material of your choosing, as long as you choose a material that the machine is okay for. If you want to buy a big Tormac or Haas CNC machine, and you can cut steel and 5-axis machine and do all kinds of things, excellent, great. I would love to have one in my garage, but that's just not in the budget, and it's not necessarily going to be appropriate for every instance. What you kind of need is the opposite, or the inverse of a 3D printer, where a 3D printer uses a relatively low cost gantry system, XYZ gantry system, to move a tool around that squeezes out plastic. You kind of want the opposite of that. You want a relatively low cost XYZ lightweight gantry that moves a tool around that removes material. And that's what EDM or wire EDM is really, really good for. And the material that it removes can be steel, aluminum, titanium, pretty much anything that is electrically conductive or can be made electrically conductive. So this version of an EDM machine comes from Rack Robotics. John over at Rack Robotics came up with this design. Like I said, fits in a 10-gallon aquarium. So again, we kind of have those constraints. So how can we make this into kind of a, compact package? The aquarium part is important. Aquariums hold water, and you need water to make EDM work, or a dielectric. It's generally water, distilled water, that's constantly kept flowing through the cutting surface to wash away swarf and keep the wire from actually physically contacting the machining or the stock to be machined. So you just basically want to keep an electric arc going that erodes the material slowly, but in a very controlled and very precise way as the wire moves around under CNC control. That's not an easy trick to do on the desktop, but John has managed to get this whole package together and into a tank, and keep all the electronics above waterline. The motors are up above the waterline, and the power is transmitted down into the water through shafts. So you don't have the complex problems of waterproofing or the expense of buying waterproof motors. The PowerCore EDM power supply, which we've previously featured, and we'll put a link for in the description here. That's kind of the brains. The brawn is this bit that John designed that moves the wire around under CNC control through the stock in the tank. I kind of think it's a brilliant design. The fit and finish on the 3D prints that went into the gantry and all the other parts is really, really nice. It's a Core XY platform to move. It's actually a double Core XY platform. Two Core XYs kind of stacked on top of each other to do the X and the Y. I thought that design was pretty brilliant. And I just love the quality of the cut, the look of the metal as it's being eroded after it's eroded is just gorgeous. The finish. The thing that's really nice about EDM in general, wire EDM in particular here, is the lack of machine forces. I mean, when you've got a rotating tool that's digging into material and spitting out chips, you've got huge forces that have to be corralled and maintained, and that's where you end up getting massive castings for the moving parts and huge heavy machines that have to be moved in with a forklift, and all that rigidity is necessary to contain the massive amount of force that needs to be applied. Plus there's the heat of friction that you have to manage with high flow lubricating oils and solutions, and it ends up being a mess. It gets a lot of work done, but it's at a high cost. And these machines, potentially, if we can kind of get along to the point that 3D printing has gotten to, where you can buy one for a couple of $100, not even. You could buy them at Aldi's for like $80, I think. If you could get to that point with wire EDM and be able to machine, 40 millimeter thick plate stock, it takes a long time because it's a slow process and you go through a lot of wire, EDM wire. But if it's one of the kind of things where you can set and forget it and just come back to these, massive, big, chunking parts that have been made for you and have beautiful finishes and are super precise. Wow. Sign me up. I would love to have a machine like that in my shop.
I'm glad you mentioned the 40 millimeter stock, because that was kind of the most impressive thing to me. Is the video starts with these little pieces of sheet metal, and it's like, that's cool, okay, fine, I could see that being interesting. But then like they start doing like these torture tests, and then you start realizing like, oh wow, no, this thing can chomp through some metal. I mean, like it says, it's gonna take time, and it's maybe not the most efficient process, but I mean, you're not like you're limited to 2 millimeter thick stock or something with this. You could work pieces of metal that would be a serious challenge, even if you had the patience to do it with an angle grinder and a hacksaw or something. Just the size of the stock here is really impressive. And I also think it's interesting, if I understand it correctly, just the power supply, right? Like that, like there's none of the other, because the power core did have its own motion, but I think that was like a modified Ender 3 or something, right?
Yeah, I think that's what it was. Yeah,
not quite up to the challenge of some of this, heavy duty stuff. So I think it's interesting that they kind of took that, instead of reinventing the wheel, right? They said, okay, well, we already have like an open source EDM power supply out there that works great, and they already did their own Kickstarter, and presumably they're already in people's hands, right?
I believe so.
So they said, okay, we'll take that, and now we'll build, like I said, a much bulkier machine around there. It's a little bit like the early 3D printing. Somebody would have an idea, like, oh, that's a good idea. But what if we did this? And they kind of start building onto it, and that's always better, at least in this kind of open source community development, than infighting and, well, this is the way I want to do it, and I don't want to do it that way. So it's encouraging, I would say, that we're starting to see this kind of thing so early, and who knows, this might evolve like 3D printers have, out of the rep wrap to, like you said, something you get at Aldi's for under $100. It is really kind of amazing to think of how far it's come in a decade and a half, maybe.
Yeah.
I don't even know. It hasn't even been a full 20 years, I don't think. So yeah, I mean, it's cool to see like the birth of a whole new desktop manufacturing technique, and I could definitely see, even if this is not the kind of thing that's like in every maker's workshop, it's the kind of thing that you would definitely see at like the local maker space, right?
For sure.
For that time that you need, the PLA is just not going to do it for you, and whatever that part is really needs to be out of aluminum or brass or something. It's going to be really, really good to have this kind of technology in the hands of the maker community.
I think it's going to be a game changer for quality parts and precision parts that you just can't do right now on any other kind of modality that we currently enjoy on the desktop. So looking forward to seeing how this develops.
This next one I'm very excited about, but I feel bad because I don't think Dan's going to be interested in it. This doesn't seem like a Dan thing.
It doesn't seem.
And I think you have to be of a certain age to appreciate this.
You're going to go there, are you?
Oh,
jeez.
It's all right. You're greater years. You have more experience than I do.
Nice cover.
But static recompilation brings new life to N64 games. That's the headline. What does that mean? That sounds like a lot of words. Basically, we've been able to emulate the Nintendo 64, like a lot of the other vintage consoles, but the N64 is actually a very complicated machine. So even on a modern computer, it's surprisingly hard to get good frame rates and to do it well. So what this project does is it actually takes the ROM from an N64 game, extracts the assets, the textures and that kind of stuff, and takes the binary and is able to reverse it back into clean enough C code that it can be compiled and turn it into a modern PC game, which is kind of mind-blowing because there's no more emulation at all at that point. You're not pretending to be an N64. You're just saying, hey, have fun on a modern computer with 12 cores and 32 gigs of RAM and a modern video card. And of course, the game doesn't know how to take advantage of any of that, but the potential is there for it, right? And this first kind of shot across the bow to show that it will work. They've taken Majora's Mask and they've run it through this, and they've turned it into effectively like a modern PC game that builds on Windows and Linux, and it's got proper like menus with sliders for the resolution and all that stuff, like what you'd expect in a PC game, but it's also still Majora's Mask from, whatever, 2000 or 99, whenever it came out. And it's kind of like a revolution in the way that these old games are, going to be playable. And even, there's talk, we've covered it before, that, some of these things are kind of almost like lost media, right? Because the hardware is too old, and emulator is too hard, and these games, maybe they can't be played for future generations. And I mean, I'll admit there's probably things more worthy of preservation than video games, but still, it's an art form, right? And you don't want to see any kind of art go away. So this has the potential of letting, it's C code, right? So you could compile it for anything. You could compile it for a modern game console, do it for your phone, for your toaster. Really, I mean, it's very cool. And once that hassle of having to emulate the N64's weird architecture goes out the window, now you can just start seeing some incredible performance gains, and they're already running these things at 4K and ridiculous frame rates. So I'm very excited. Like I said, this has a nostalgic kind of bend for me personally, but I also think from a technological kind of standpoint, it's really incredible to be able to take these, games made for a very specific set of hardware and then open them up to be, native programs. And you also got to wonder, is this something that we could start seeing for other platforms too? Now that the genie's out of the bottle and this stuff's out there and it's open source, and they've documented how all this works. Is emulation going to be kind of like a thing of the past, right? Like, do we just start saying that, forget emulating them, we just translate them into modern native apps for whatever we have now, and everything enjoys modern hardware and everything that comes with it.
Well, I mean, this example is video games from the early 2000s, and that's perfectly fine. Like you said, I don't really have much relationship with Link and Zelda and all this, but back in my day, it was 64-bit computing. No way, man. We had 8 bits and we liked it that way. But your point about it, having other applications, maybe you start seeing these systems we keep hearing about, the Amiga that's running the school HVAC system for the past 40 years and nobody touches it because it's working fine and they can't replace it, or the governments are running applications that are written in COBOL, but nobody bothers to touch it because if you touch it you break it, and if you break it we're out of business. Maybe then you can take this kind of technology and say, okay, look, here's the weird architecture machine that it used to run on. Here's the code. Figure out how to make this run on a machine that we can actually, purchase right now and maintain and have some hope of it having a future, rather than waiting for the capacitors to dry out in this thing and finally for it to go belly up. Maybe the video game is it's the bait that gets people into the trap, and then the trap is finding other useful, perhaps putatively more useful ways to put this to work.
Well, I mean, the entertainment industry has certainly pushed technology that has flowed over into other things. You start doing it for games, and then somebody's like, "Well, wait a minute." I actually work for a living, and we could use this same thing for something that will make us more money. Yes, I think the technology is really cool. And I should also say, and even in this write-up, Maya mentions, it's not just like click a button and you get portable code, right? There's obviously going to be, but if it could get you 85% of the way there, you know, and the rest is just chasing down those last kind of exceptions that, you have to write some little glue code. I mean, that's pretty impressive. And as much as I'm interested in playing some of these games from my youth at 4K and 300 frames per second, I do really want to see where this technology can go outside of that.
Alrighty, next up for me, student's leaf blower suppressor to hit retail. So, the leaf blower is both the bane and the essential tool of suburban living. You know, when someone else is using it, they're an idiot. When you're using it, you're a genius.
Like Excalibur,
Yeah,
you know.
exactly. When I wield my leaf blower, I'm always very conscious of the fact that this sounds awful. I don't want to be doing this any longer than I have to. Mine's gas powered, I'm sorry to say. The gas ones are bad enough. The electric ones, however, have a certain tone to them that's absolutely ear-shattering and travels so far in the neighborhood. You know when someone's using an electric leaf blower. It's this banshee scream, high-pitched, shrill, terrible sound for some of them. These students from Johns Hopkins University have figured out how to get a 3D printed add-on for a more or less stock electric leaf blower. They chose a DeWalt, and put this in the nozzle of the leaf blower and reduce the sound signature considerably, and not completely, but it does change it changed not so much the quantity of sound. The loudness is still there, but it shifts the frequencies to a far less annoying kind of mix of sounds. They've got a before and after sort of thing in the video that's attached to this article, and the difference is considerable. And I would certainly rather be next to the suppressed leaf blower or hear that operating in the neighborhood than I would the non-suppressed version.
We noticed a very high shrill at really annoying frequencies, and we wanted to remove that.
Our product makes the blower less noisy.
It ultimately dampens the sound as it leaves, but it keeps all that force still there, which is the beauty of it.
The noise is deeper, so it is not screechy.
It's the difference between hearing kind of a high-pitched whistle and hearing what you might just think being wind noise.
The thing with this, that as the headline says, that this is going to be commercialized at some point. They've gotten together with Stanley Black & Decker, who's the parent company that makes DeWalt, along with dozens of other brands of tools, including Stanley Black & Decker. That they're going to incorporate this design into their leaf blowers, and it's not clear what sort of compensation, consideration of any kind that was made. I would assume that, you know, Johns Hopkins University is in on the mix because the students were, you know, they were students of Johns Hopkins at the time, so they've probably got a claim to the IP here. They also don't really tell us exactly how this works. Obviously, they've got some sort of probably some sort of NDA with Stanley Black & Decker to protect the IP. But we get a few clues about how it's done. First of all, it's a 3D printed add-on. Second of all, kind of the look of it sort of looks like it's inducing a vortex of some sort, because it's got these deep screw threads that look like they would sort of be not an impeller. I don't think the actual suppressor has any rotating parts. I think it's all passive. I think what it's doing is probably redirecting the airstream and trying to attenuate those more annoying frequencies in the spectrum. So the details are a little rough, but it's kind of cool to see a 3D printed student project being picked up by a major, you know, multinational corporation for possible incorporation into one of their flagship products. I think that's pretty neat.
Yeah, and I think, like you said, that pending commercial arrangement, I think, probably does have some impact on why there isn't a whole lot of information here. We've seen usually when these university projects are done, there's a paper, right, that accompanies with them, and usually the school's pretty say, hey, read what our students are doing. It's kind of a badge of honor thing. And I looked around and I if it's there, I can't find the paper, right? And even in the write up, they could be more open about what's actually happening, know. But like you said, it seems like it's just taking some element, some amount of the air, slowing it down through those channels, and then dumping it back into the airflow. I thought it was interesting that they kind of came at it without any assumptions, and it says in there that they originally they took the whole leaf blower apart to figure out what the noisiest part was, and at some level they must have figured well, it must be the motor, must be the motor or the fan itself, and we're gonna dampen that somehow, we're gonna tweak it, and that ended up kind of being a dead end because they found that the noisiest part wasn't the mechanical aspect at all. It was the weird interaction of frequencies that are happening at the nozzle, where you have all this mass of air, ripping by the plastic, and then they kind of, armed with that, they said, well, all right, you still need the air to come out, right? It's a leaf blower. You can't just be like, well, I'll slow it down, because then you might as well get a rake, right? So they knew that wasn't an option. So like you had mentioned, they identified these particular tones that are the most annoying, and were able to, and that's where the blank line is, because somehow this thing addresses those tones, which is the part I'd love to see more about. But someone actually in the comments did kind of, they linked to some similar research, and they had kind of proposed their own DIY version. So maybe we'll have more answers. But yeah, I mean, it is really cool that so quickly this thing has been picked up for commercial use, and I'd love to imagine that we'd be able to as seen on TV, buy these little add-ons for our blowers. But I know the reality is that they're going to have the new 2026 model year blowers will have this thing integrated, and you have to buy a whole new blower just to get this feature, even though it was demonstrated as a simple and cheap 3D printed add-on for any blower. But that's progress for
and it'll
you,
use
right?
a different battery.
Yeah, oh yeah, by the way, you need to you need to get the new battery. And do we mention there's an app that you have to download? It's still cool to see this getting out there, and even there's a kind of a quote from the Stanley rep to say it's rare to see this kind of night and day, oh damn, that really works, is rare enough in the industry right now that they snapped this thing up before it even went before the news even came out. They must have moles inside John Hopkins. I am interested to see, if not now, at least when these things are on the market and somebody can cut one open and take some measurements, if it'll be possible to re-engineer and get back to the cheap 3D printed add-on that we could just snap onto our blowers.
And I wonder how crucial the 3D printing part of this is to how this operates. The test would be whether you take this exact part and you do it in injection molding, because that's what everybody does with plastic parts, right? When you want to build them, build a lot of something, do this in injection molding and find out it doesn't work. Perhaps I'm not saying that's the case. I'm just saying perhaps. And that could be because the layer lines are actually doing something. How shark skin is supposed to be very hydrodynamic, because the rough surface of shark skin kind of breaks up the laminar flow somehow. I don't know what the physics are of it, but it's supposed to allow sharks to swim super fast through water, obviously. Well, maybe the same thing applies here. Maybe that those irregularities that are introduced by the layer lines, maybe they're actually doing something. Maybe there's actually a function to them, and we'll find out, later when the injection molded doesn't work, but the 3D printed does. Again, I'm not saying that's the case. I'm just, just conjecture here, but this may be one of those cases where a 3D printed part is superior to an injection molded part.
Well, that's an interesting point too, because the additive manufacturing is one of the things it is uniquely good at is building internal channels and stuff.
Right.
And we've seen that for like 3D printed rocket engines, and they can, back in the Apollo days, they had to wrap the combustion chamber with copper to pump the propellants through, and now they can just print those channels directly into the walls of the chamber, and that's something that is, you don't like to use the word impossible, but would be very, very difficult with traditional, fabrication techniques. So it'll be interesting to see, one, how do they translate this into a non-printed design, because it has those internal channels, and like I said, does it work the same? And that would be interesting, to say, hey, it turns out it's much harder to injection mold this than we thought. I mean, I guess you'd have to do it in multiple parts, right? Like you'd have to do the spiral thing as its own part, and then probably to inner and outer wall. I don't think you could do it in one shot the way it is. It's too complicated inside. So that'll be kind of cool, actually, just to, whenever they hit the market, look at it and just say, how
that part is made.
Yeah, how did they make it from this original, and you have to figure the students, their goal was just to make the thing quieter. So they're not designing it necessarily for any particular production capability. They had a 3D printer at school. That's what they're using. You know what I mean?
Correct. Yeah.
And they played to its strengths. And then now somebody comes in and says, "Oh, well, okay, how do I make 1 million of them for 3 cents each?" And it's like, well,
that's
I
your
don't know that part. yeah, like I already got an A. Like, all right, this next one, talking about the challenges of 3D printing and the unique aspects of it. This is this Wi-Fi filament sensor is unnecessary but awesome, and I should say I wrote the headline, and I kind of went back and forth on it, because I didn't want to like throw any kind of shade to the project. It's a very, that's why it says it's awesome. It's a very cool project, and it is really, really impressive. But you probably don't need it. And like, when has that ever stopped us, right?
Right.
Like if you're going by, the metric is, do I need this thing that I saw on Hackaday? Good luck.
Yeah.
But in this case, it's a Wi-Fi filament diameter sensor, and it's a real-time kind of deal where the filament's coming through, and you can pop open a web browser to see the interface, or there's like a REST API too, and you can see in real time, boom, 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 all the diameter measurements to see how consistent the filament is. Now, maybe you don't have a 3D printer, even if you did, you've probably never given much thought about this, but there was a time when like the filament was much jankier and the extruders were poorer and everything kind of was just worse. And you might actually run into filament that wasn't at 1.75 millimeters. It might be a little bit too thin, or if you're in real trouble, even fatter. And you could get these inconsistent results in your print in the best case, and worst case, you might actually jam the extruder, and then, it was a whole thing. So there, at one point, it was believed that a good idea would be to put a sensor like this, before the extruder, say like right out of the, right when it comes out of the roll, and like hook that up to the printer's main board, and have it dynamically adjust like the extrusion rate for how thick the filament was. And this would, it wouldn't help you jam if it was like a weirdly, fat filament with a bulge or something. But it could at least help with those inconsistent print results where like you'd see gaps in the walls and stuff because less plastic than was expected came through simply because the plastic filament was smaller. These days, like nobody's worried about that. Like the filament is way better. The printers are better. Like everything is nobody cares about. Like just, if you're just printing. If you're just printing, it's a cool thing. make it if you want. It's open source hardware and software, but you don't need it. The people who do potentially need this, though, are the folks who are making their own filaments.
Right.
You know, they're whether you're doing it from plastic pellets or, you know, we've covered projects where they're pulling Coke bottles apart and running that through into the thing. You know, okay, if you're doing that, you want to see that your diameter is where you expect it. You know, and maybe if you are like the super, optimization type, you still want to make sure your extrusion multiplier and stuff is perfectly dialed in, and you want to double check that this is, what it says on the tin. Interestingly, actually, like, if you buy Prusament, they do run it through a machine similar to this, and each roll has like a little report that says like what is its average, average deviation from the norm and stuff. So they've done the work for you. So even if you were worried about it, you could just look it up on the website. But hey, let's say you don't trust big filament and you want to be able to double check the figures. Mechanically, it's really cool. It's a pair of bearings. One's fixed in position. The other one's attached to a movable arm. End of the arm, you got a magnet that's positioned over a Hall effect sensor. You could probably visualize it as I'm explaining it, but the filament goes between the two bearings. Any change in the filament size makes the arm move up and down. The Hall effect sensor picks it up. You map raw data to diameter, and boom, you have a really elegant, super reliable. I mean, if that thing's going to work until the magnet loses its juice, and by that point you'll have bigger concerns than your desktop 3D printer, right? It's a very cool design. It's actually based on Thomas Sandlander did one a few years ago using the Tyranny. This one now is same mechanical concept, but uses the ESP32 because you wanted the web interface and all that kind of jazz. So just a really cool refinement over what I'd almost say is like a relic from 3D printing past, but still has some hardcore uses. And if you're somebody who's making your own filament, which is something that's becoming bigger now, actually. This might be just what you were looking for. So,
I kind of almost don't see the use case for it for filament makers either. You can't do anything about the fact that your filament's thin or thick. It's set in plastic at that point. I mean, all you can do is document the fact that it's.
And get mad about it,
and right. Potentially diagnose the problem. But it's not like you can take the the bad section out and glue the two ends together, and that's probably not going to work as well as. I mean, it's probably going to be as much a problem as the thin or thick section would have been in the first place. So, I guess you could sell short rolls or something like that, or whatever. So I almost don't see the point of it, but I do see, I do appreciate the engineering and the thought that went into it. It kind of reminds me of another story that I did this week, about a sort of a flexure-based displacement sensor that a fellow made and did basically it's a dial indicator, but an electronic dial indicator to measure run out and things like that. So instead of buying an actual digital dial indicator that you can wire up, made the sensor that had instead of a Hall effect sensor, which is what I expected to see in this particular device, he used a photo transistor, one of the regular interrupters, for the photo interrupters, and kind of a 3D printed knife blade on the end of a flexure to keep everything rigid and moving in one plane. And the knife blade occludes more and more of the light as the deflection increases, and measure the current through the transistor and current or change it into a voltage, measure the voltage with an Arduino, plot the numbers, calibrate it, all that stuff, and you get a sensitive displacement sensor. But I thought he would probably have used a Hall effect sensor. I wonder what the relative benefits of Hall effect displacement versus phototransistor displacement are. Is one going to be better than the other in some way? I could see like in a situation where chips are flying, you probably don't want to use a magnetic sensor. Maybe more of a sealed optical sensor would be better, or I don't know, maybe not. Maybe one's better than the other in terms of precision and sensitivity and things like that. I don't know. I'll put a link to that one in the show notes, and you can check that one out too, because they're kind of similar, at measuring very small displacements, and it just occurred to me that you could probably use either one interchangeably. Okay, my last pick is filming the eclipse from 80,000 feet. Now, obviously, this has to do with the recent eclipse, the one in April. And this actually is a repeat attempt from the 2017 eclipse. Tariq Akazazi and Kemfik decided to launch a balloon and film that first eclipse in 2017 from great altitude. And one thing led to another. Didn't really work out in 2017, but as luck would have it, 8 years later, they'd have a chance to give it another try. And so the project video that goes along with this is sort of a long video that captures the whole process of getting ready for this, of building the balloon. The payload was to be a glider that would break free and return. The glider would carry the cameras and the radios and all that stuff. But we've seen that set up before, the glider return from the space balloons a couple of times. And the long story here, the short story, the short version of the story here is that they managed to actually get to 80,000 feet, or however many meters that is, during the eclipse. And they did manage to recover the glider, but it wasn't right away. It was almost a month or more than a month later that they actually found the glider. The video goes into great detail about that and the tribulations of actually trying to find the glider and recover their footage. I will say I have kind of mixed feelings about a project like this. While I absolutely appreciate the effort of anybody who did anything other than just sit there and watch it, there's something to be said for just sitting there and watching it. Actually just watching the whole thing unfold before you without worrying about cameras or radios or balloons or whatever. And just sitting there, keeping the glasses on until that last minute, taking them off, seeing totality, grooving to it, watching the bugs and birds come out that don't know that it's not nighttime. All of a sudden they're active, feeling the temperature change and just taking in that whole experience. I super appreciate the amount of work that went into launching a balloon and getting video of the eclipse from up high. But to me, I would just rather sit there and watch it and, hang out with family and friends and be sort of all in that moment together.
I gotta say the Hackaday podcast is a pretty bold podium to advocate abandoning technology and living in the moment. But for anyone who hasn't turned off the podcast now to go live in the woods,
have I inspired you?
Thank you for staying with us. So for my first quick hack, I've got trying to build a communications device with a 1-pound laser and a 7805. And I should say here, this is perhaps somewhere where, an editor of Hackaday should have stepped in, because I also thought when I first saw this that it was, a laser that weighed a pound. And I was like, I wonder what that's going to be, like some kind of old school, No, we're talking about the currency pound. This is a cheap little red laser module. Beamer wanted to see if he could use these cheap laser modules to send some kind of data across, and came up with a cool little circuit that uses a 555 timer into the 7805 to produce pulsed power, and then that gets picked up on the other side with a photodiode. Next up is Scott Manley explains GPS jamming. On this one, he's talking about just basically how the GPS works, how it can be jammed, how it can be disrupted and spoofed, and jamming is easy. Spoofing is, as you can imagine, a little bit more complicated, but has been done in the wild. So it's just an interesting explainer about how this technology, that we, really rely on to an exceptional degree, how fragile it really is, and kind of give you something else to keep you up at night. And my last pick is Amber Compiles to Bash. This is a cool little software project where you can write scripts in a, I'd call it Python-like language with all the modern fixins and sanity checks, and it will build that into a bash script that you can run on your Unix box. Pretty cool little thing. If you ever had something you wanted to do in bash but were too afraid to try, maybe this will finally help you out.
Okay, first up for me in Quick Hacks, how to lace cables like it's 1962. Cable ties, zip ties, wire loom, forget all that stuff. Give me some nice waxed flat thread and a bunch of wires all pointed in the same direction. Lace them up nice and tight. That's some stuff right there. This is a summary from a guide from the U.S. Navy, I believe, Bureau of Naval Weapons, on how to lace cables. And the whole thing of lacing cables is to get them bundled beautifully together, neatly, tightly, but not too tight. No problems with penetrating the insulation or causing sharp bends that might be wear points later on. The workmanship here is exquisite, and I would love to have a project where I could justify the amount of time it would take to do this. Next up, ribbon cable repair saves Touch ID. Ribbon cable, I think when I hear ribbon cable, I think of those 25-pin multi-connector kind of things that you would see a printer connected up to a computer in the old days. That's not this. This is more like flex cable repair, flexible PCBs where the traces have broken for whatever reason, probably because of flexing. Master Lou demonstrates how you can repair those in a very brief video that shows some sped up repairs with a soldering iron, a bunch of solder paste and flux, and a little dab of what looks like UV cure resin to hold it all together. I always love these heroic repair videos, and this is one that's particularly challenging and was also quite satisfying. And finally for me, PyPico helps restring badminton rackets. Who knew you needed to restring badminton rackets? You just buy the $5 kit when it's Memorial Day and you go play badminton on the beach, and then you throw the thing away. Apparently not for some people. It's a more serious sport than that, and you can actually need to have a tightly strung, correctly strung racket. Quo built a machine to help do this. Now, I thought at first that this would be a machine that would actually do the weaving of strings in and out and the weft and the warp and all that, but no, this is actually more of a tensioning machine. The actual stringing is done manually, which, I mean, you can't blame anybody for doing that. That's a pretty hard task to automate. But getting the strings at just the right tension is the job of a linear actuator, a strain gauge to measure the force, and an Arduino to put it all together. So this actually helps string it. This is more of a tensioning tool, like I said, than a stringing tool, but still a useful thing for the badminton enthusiast.
Now we've come to the can't miss articles part of the podcast. This is where we pick 2 original content pieces from our awesome staff of writers. And my pick this week is Lewin Day's Single Stage to Orbit, the launch technology we wish was real. And as a confirmed space nerd, this is one of those ones that I almost wish I had written up before. I wish I'd beaten him to the punch, because this is a very cool thing that I think anyone who's been into either real space flight or even, sci-fi space flight has always kind of, wondered about this. You look at, say, Star Trek, for example, and, they have these little shuttlecrafts that can, take off from the ground, shoot up to space, fly around, and just do that all day. And, that's a real far cry from how we actually access space, where you have this giant hulking rocket that expends, 90+% of its liftoff mass to get this tiny little tin can into orbit, and can do it once, right? And the reason for that is because, chemical rockets are not a great way to get to space, but it's the only way we have. The energy you get out of it just isn't a lot in the grand scheme of things. So you require so much of it that whatever's left is in the absolute minimum. It's not unheard of for less than 10%, for some of these rockets. It's documented for like the shuttle and Soyuz and Falcon and all. They all have like it's called the mass fraction, and it's how much of their actual pad mass is payload, and they're all around 6 or 7%, I think. And that's considered state of the art, right? That's the best we have. And Lewin goes through sort of the concept of, what would it take to have some kind of a vehicle that could just lift off the ground, fly all the way to space, not have to dump its fuel tanks off, and could arrive in space in the same condition it was when it left the ground. And, the answer, at least on paper, is that it's like just on the cusp of possibility with chemical rockets as we understand it. But it's super, super hard, and no one has ever actually done it. There's been several attempts of varying degrees of seriousness. They all had, extreme promise. I mean, at one point, Lewin talks about the Venture Star, which was almost the assumed successor to the space shuttle. If you were looking at, popular science and stuff in like the mid to late 90s, like that was it. Like, okay, yeah, we're gonna, retire the shuttle, and the single stage to orbit Venture Star, that's gonna be the future. We're not gonna need the boosters, or we're not gonna need, like, this was assumed to be the future, and then that pesky reality sets in.
And I've said it before, I think I've even said it on the podcast, but I'll say it again. We're spacefaring as a species, but only just barely. I mean, we're spacefaring to the same degree as, a prehistoric person who wove together, twigs and reeds into a coracle that is possible to use to like cross a river or a small pond or something like that. And then they take it to the ocean and they say, well, let's go. And, maybe they'll get across, from like the English Channel or something like that by luck, by pure stroke of luck. but they're certainly not going to get very far across the North Atlantic to, from Europe to, the New World. And I feel like that's kind of where we are with spaceships. We get, we've nailed low Earth orbit. That's fine. We can do that. But again, only kind of just barely, because like you said, 90+% of what we build just goes to either air pollution or ocean pollution, right? I mean, everything just crashes into the ocean. Maybe we recover it, maybe not. But that's more of an economics thing than anything else. That doesn't make it any more or less possible to do this. It just makes it more affordable. So until, and I think what you said is true. The chemical engines are just a terrible way of doing this. That's all we got, though.
Probably have heard the figure that, if the Earth was a little bit bigger and the gravity was just a little bit more, we wouldn't be able to get to space at all. Chemical rockets operate within such a narrow window of physical possibility. You know what I mean? Like we said, you're talking less than 10% of your vehicle is the usable payload. So if gravity was 11% higher, we wouldn't be able to get off the ground at all.
That's interesting. That's an interesting point. I hadn't thought about that.
One of those cosmic coincidences that we're even able to make orbit. It's so close to not happening.
Okay, and my pick this week completes the sweep by Lewin with his peaking underground with giant flying antennas. Now, the black helicopters are a trope, of course, but in a lot of ways they're not, because there's a lot of helicopters up there and they're so darn useful for so many purposes, and that you see them flying around all the time. Me, for instance, I see helicopters all the time flying pipelines around here, doing inspections on pipelines. They are literally black helicopters, and they show up on the ADSB as Department of Energy helicopters. So that's always a little bit scary to someone who's prone to paranoid thinking. But what Lewin's talking about here is probably actually would look pretty similar, except for the fact that these helicopters have giant dangling octagonal or hexagonal antennas from that dangle from them on long lines. And the purpose of these antennas is basically to examine the magnetic field of the Earth. Now, we tend to think of the Earth's magnetic field as fairly uniform, and that's anything but the truth. The Earth's really lumpy. They say that if you scale down the Earth to the size of like a billiard ball, it would be smoother than a billiard ball, because the actual peaks and valleys are almost nothing compared to the radius of the Earth. But inside the Earth, the distribution of material in there is very much non-homogeneous. There's big domains of magnetic rocks here and there spread all over the sphere inside the Earth, and it makes for the Earth's magnetic field being very uneven. And you can learn a lot about what's underground by examining that magnetic field. So these helicopters with these giant antennas are part of these geological surveys that are used to map what's all underground. And that could be anything from, like I said, the rock structure, to voids in the rock structure that would lead to underground resources like water, aquifers, be underground minerals, could be oil and gas for exploration. So geologists use these giant flying magnetometers as methods of figuring out what's underneath the ground.
I'd like that he gave some links to where there's public data on some of this. U.S. Geological Survey has been doing it. And it says California Department of Water Resources uses it. I always like the articles where, and you've done a lot of these too, and I often find myself picking yours for the can't miss, because I do like the ones where you just take some kind of like little known piece of infrastructure or something and just kind of do a deep dive on it. And it's one of those things that's it's happening out there, and we're largely oblivious to it unless you've seen one of these things fly overhead. The fact that you could just fly around fly around dragging this thing behind you and be able to find all these kind of things that we need, right? We need minerals, we need water, and all that kind of stuff. To do so like non-destructively is really cool. And like I said, something I wasn't even aware was happening. Well, that's it for this episode of the Hackaday podcast. As always, thanks for listening. If you'd like to see the links for this episode or any previous episode, just check out hackaday.com/podcast. If you see anything cool or do anything cool, make sure to email us at tips@hackaday.com. And until next time,
keep on hacking.
Can I go home? I need an adult.
I'm like 10 minutes into this conversation and Elliot hasn't said a thing. I know this is going nowhere, but I'm just going to keep talking.
Deciding what has to get edited out is going to be hard enough, but the real challenge is going to be figuring out how much of this we can actually leave in.